Euler's identity, named after the Swiss mathematician Leonhard Euler. It is a special case of Euler's formula for when evaluated, we substitute x with pi. In addition, it is used directly in proof that shows that pi is transcendental, implying the impossibility of squaring the circle. Yes. Okay, I'm joking, and reading off Wikipedia. But, you see, majority of the YouTube videos you find online about this topic are all really boring. I mean, they're really long, and they use really complicated math, and they all talk like Sir Pil. However, I do think that this topic is very interesting. So, give this video a try, and with that, welcome to Euler's identity for people who have short attention spans and who can't do math. Alright, first things first, we must know what Euler's identity actually is. Euler's identity is e raised to pi times I plus 1 equals 0. Now, when finished shaking from fear from seeing a math equation, we notice two major things. Number 1, there are only two actual numbers in this equation, namely 1 and 0. Number 2, there is a mess on the left. You see, just like the mess known as my room, this is where all the magic happens. So, just like rummaging through my room to find the answers to Bio LQ2, let us figure out what exactly is going on here. First thing you'd notice, or the first thing that would jump out to you, would be pi. Since we all know what pi is. Pi is 3.1415 something and something to do with circles. So that's actually all you need to know for this lesson. Rather, what's important is you know that pi in this case is something to do with circles, or something that shows that circles will be involved in it. Next is we have e and I. And now these two are a little less obvious. So let's start with I. A long time ago, there were two guys, namely Descartes and Euler, and neither of them could figure out what the answer was to the square root of -1. And just like the words Shakespeare uses, they just made one up. So, they named this imaginary numbers. Imaginary numbers are denoted with the letter I. For now, we just need to know that I is the square root of -1. And it is in a very complicated space in mathematics. This is where quantum mechanics, signal processing, fluid dynamics, and all those magical things are placed. Now, let us move on to E. And this is where things get tricky. I am saying that I'd do almost anything for grade. Anyways, E stands for Euler's number, even if he didn't actually make it by himself. Continuing, Euler's number is approximately 2.7 something. It is infinitely long and irrational, just like our buddy pi. Now, Euler's number is something very important in exponential growth, i.e. number theory. Now, exponential growth can be seen like the amount of reading material there is in bio every quarter. Okay, for real though, exponential growth is best seen through compounding interests with your bank. I.e., I have money, and I give it to the bank, I wait, and the bank gives me back the money, but bigger. And why that doesn't lead to infinite money. In summary, we have E, a number very important to number theory and exponential growth. We have pi, a number that has everything to do with circles. And I, a literal imaginary number. It gets these very important numbers established in very different branches of mathematics and fits them all perfectly in this one equation as if they were meant to be. This equation shows how everything in mathematics is connected to each other. It's the reason I'm making this cringy video. It's the Bigfoot of mathematics. It's the missing link. It's divine intervention. It's a message from God. It's beautiful. Hence, Euler's equation, or Euler's identity, is dubbed as the most beautiful equation in mathematics. Oh, by the way, some of you are probably like, wow, that's really cool and all, but is it useful? And to you, I say, it's as useful as modern art minus the money laundering.